In this lesson, we are going to determine the molar mass of an element and compound. We've already looked at the definition of a mole, that it's just a counting number, much like a dozen or a pair. So when we look at the molar mass of either an element or a compound, what we're looking at is the mass when we have 1 mole of that substance. For example, if I have 1 mole of an element, say carbon, we would say I have 1 mole of carbon. That means I have 6.022 times 10 to the 23rd atoms of carbon. Because a mole is just that counting number. Just like if I said I had a dozen carbon atoms, that would mean I have 12. Anytime I see mole, that just means I have 6.022 times 10 to the 23rd of those things. So what I look at is I look at the periodic table, and for carbon, I'm going to look at its atomic mass. So that's here on the top in this particular diagram. And so if I have 1 mole of carbon, that means I have 6.022 times 10 to the 23rd atoms of carbon. What that tells me is that it has a mass of 12.01. I'm going to go ahead and round this to 2 decimal places. 12.01 grams. And we represent that by saying 12.01 grams per mole of carbon. So we could do the same thing for nitrogen. Again, we would look at the value given in the periodic table. So for nitrogen, it would be 14.01 grams per mole of carbon. And we can do this for every single element in the periodic table. Now, when we look at a compound, what we see is that we want the mass of 1 mole of the units of that compound. So let's look at the compound of carbon monoxide. So capital C, capital O. Notice there are no subscripts, and that tells us that we have 1 carbon and 1 oxygen in each molecule. And so for carbon, we pull that information from the periodic table, and we see that it's the molar mass of a single carbon is 12.01 grams per mole. For oxygen, it's 16.00 grams per mole, and together we get the molar mass of a compound simply by adding those two numbers together. So for carbon monoxide, CO, it's 28.01 grams per mole. And instead of being per atom, or 6.022 times 10 to the 23rd atoms, now we say this is for 6.022 times 10 to the 23rd molecules. So we can change what we're counting, but the definition of a mole doesn't change. Just like we can have a dozen books, a dozen pencils, a dozen people, a dozen donuts, it still means we have 12, and that's all a mole means. The way we get to the value of a mole comes from a scientific background, but for us, we're just going to be worried about what does that mole mean. Now you will see things referred to slightly differently sometimes, and you'll see something called AMU, which stands for Atomic Mass Unit. And when we see that, what we're talking about are very, very small masses. And so the molar mass, that numerical value, actually can be used in 2 different ways. And this is true for both compounds and elements. So when I'm looking at water, for example, if I have a single molecule of water, so 2 hydrogens and 1 oxygen all by itself, that single molecule, it would have a mass of 18.02 AMUs. If I have 1 mole of water, so I have 6.022 times 10 to the 23rd molecules of water, we would see that it has a mass of 18.02 grams per mole. Same number, different units associated with it, depending on whether we're talking about a single molecule or a mole of molecules. So let's look at an example where we find the molar mass of MgCl2, magnesium chloride. And so this is often the salt that's used on streets in the wintertime to help lower the freezing point of water so that we don't have ice on our streets, that we have liquid phase water. So what we see is that when I look at the formula of magnesium chloride, there's no subscript by the magnesium, and that tells me I have one magnesium. In chlorine, I see a subscript of 2, so that means I have 2 chlorines. So we have 1 molar mass of 1 times the molar mass of magnesium plus 2 times the molar mass of chlorine. These values I get from the periodic table. So looking at magnesium, I see the atomic mass is 24.31. For chlorine, it's 35.45, and I simply do the math and find that the molar mass of magnesium chloride is 95.21. The only difference between the example we looked at here and the carbon monoxide is that now we have this 2, which comes from the subscripts, and so we have to account for that when we look at the molar mass of a particular compound. So let's let you try one. But first we want to look at how many atoms of nitrogen and hydrogen are in this compound. It happens to be called ammonium dichromate. So when we look at the formula, we need to remember that for the nitrogen and hydrogen, that subscript that is outside the parentheses actually belongs with everything in it as well. It tells us we have 2 of the NH4 groups. So for nitrogen, we see that there's no subscript, which means it has a subscript of 1, but there are 2 of those NH4 groups, so that means we have 2 nitrogens. So we can eliminate answer A and C. And it has 4 hydrogens, but there are 2 groups, so that's a total of 8 hydrogens. And so D is our correct answer. Now when we're looking at the molar mass, we do have to consider every single element in that compound. So now we want to look and find the molar mass of ammonium dichromate. When you enter your answer, you should report it to 2 decimal places. And you do not need to include units in your answer. This is important to make sure that the question is graded correctly. So the correct answer will be 252.08 grams per mole. Now note that your answer may vary slightly in the last decimal point, so you may have gotten 252.06 or '07 or '09, and there's a range of answers that are correct, so we will see some variation in molar masses depending on the numbers you use to add up the values. So we've already established that there are 2 nitrogens and 8 hydrogens. There are also 2 chromiums and 7 oxygens. So we need to take 2 times 14.01 for nitrogen, 8 times 1.008 for hydrogen, 2 times 52.00 for chromium, and 7 times 16.00 for oxygen. And when we add up all those values, we end up with 252.08.